Ensemble models take our deterministic models and basically run the initial conditions and the data that's put into the model with multiple different iterations. So basically, let's say you have the GFS. The GFS has a set of initial conditions, and the model is run based on that set of initial conditions. The Ensemble GFS would take those initial conditions and tweak them ever so slightly, tens, dozens of times, to get a bunch of different ensemble members that have slightly different initial conditions. And then the model will run all of those different iterations to come up with a bunch of different members and then average those members, average the solutions of all those members. So it actually gives us a little bit more accurate of a picture than just taking the deterministic GFS, for example, and taking that at face value. We actually get a bunch of different initial conditions, bunch of different possibilities for those initial conditions that are fed into the model. And then we average the solutions from the model that's run off of all those tweaked initial conditions.
Join our channel membership and unlock instant access to full-length storm chasing presentations. Click the subscribe button below and then select join, or just click the join button on our profile page.
For example, here is the GFS ensemble, or the GEFS, and these are all the different members that the ensemble has. So you can see there are 20 different members here. That means there were 20 different little tweaks to the initial conditions fed into the model. And that leads to forecasts that are just ever so slightly different from each other, especially the farther out you go into the forecast period. You can see here member 1 has not much over the country. It's a little bit difficult to see here, but you'll notice that this one has a nice big belt of flow there over the northeast US. And then some of these, it's much weaker over there. And we have just slightly different patterns for every ensemble member. And then what is more pleasing to the eye for us is the average of those ensemble members. So this is the same model, the GEFS, the GFS ensemble. And this is the average 500 millibar geopotential height and wind. So it's basically just averaging the positions of all those height contours and all the winds, the wind intensity on each of those ensemble members, and putting it into one map as an average for us. It gives us basically a look like we're looking at any other deterministic model, but again, it's an average of all those ensemble members. So that helps to weed out the members that are a little bit out to lunch. Perhaps maybe one out of those 20 ensemble members is just way off. We can actually weed those out, and this comes up with a little bit of a better, more accurate solution for us than just looking at one particular deterministic output of a model. And the deterministic models, the deterministic GFS is a member within the ensemble GFS. So when we're looking at just the ensemble, or you're looking at just the GFS, that is one of the members within the entire GFS ensemble. Whereas this is all those members averaged together. So this gives us a little bit more of an accurate look at the overall pattern. And you can look at all those things that we talked about before: the upper level pattern, the mid-level pattern, 500 millibars, 700 millibars, 850 millibars. We can look at the average dew point. So the models, the position and intensity of the dew points are averaged over all those ensemble members, and it gives us a good average of where the moisture may be in a given setup. This is, again, the GFS ensemble, the GEFS, and the European model, the ECMWF, also has its own ensemble, the EPS. And again, it does the exact same things that the GFS ensemble does. It just deals with the construction of the European model rather than the GFS. So shows basically the same things. It's just another ensemble model that we can look at to come up with a forecast.
Remember to check out those links in the description below, and then watch another video.